Let's look at the 2017 AP Calculus A, B, and BC free response question number 1, and I will link a PDF of the questions below this video. We have a tank. We don't know what it's holding, but we have a tank. The tank is 10 feet tall, and we have a table that provides the cross-sectional area at 4 different heights, at the very base, 2 times in the middle, and then at the very top. And it appears to be a decreasing cross-sectional area as we go up, kind of like a cone. And that is true because they tell you right here, A is continuous and decreases. I would probably make a note to myself at that point. If a function is decreasing, the derivative would be less than or equal to 0. And we have select values for A of H. A, use a left-hand Riemann sum with 3 intervals indicated by the table to approximate the volume. Okay, in AP Calculus, anytime we find volume, it will always be the antiderivative of the cross-sectional area. Whatever shape the cross-section is, the area of that is what you integrate. And in this case, we have a function for the cross-sectional area. So we're going to go 0 to 10 of A of H. That is your setup. And we will approximate that using a left-hand Riemann sum, which means we need the delta H's because the delta H's represent the bases of each of the rectangles. So we have those 3 delta H's, and then we will multiply those bases times the height of the rectangles, which is your function values, and we will use the left-hand heights. So 2 times 50.3, 3 times 14.4, and 5 times 6.5. And remember on the AP exam, on free response, you must write those products. They want to see a literal base times height. Do not jump straight to 100.6. Even though this is a calculator active problem, you need to write down these products. So I am writing down the products. It does say indicate units of measure. Volume would be measured in feet cubed. You can either just kind of enter that logically, or you can go back to the original setup, the antiderivative of A of H dt. A of H is a function measured in square feet, so that's feet squared. dt represents a change. dt. Why am I writing dt? This is dh. All right, there. dh is a literal change in height, and my height is measured in feet, so that's like a dh or delta h. And feet squared times feet is feet cubed. You do not need to simplify this. Stop right there on the AP exam. The answer is 176.3. So if you did punch that in a calculator, that is what you need to write. I encourage my students that if they do simplify things to just draw a line through it. So if they did happen to make a mistake, it doesn't count against them. So on B, is this estimate, is the approximation an overestimate or an underestimate? And for left and right Riemann sums, that is dependent on whether your function is increasing or decreasing. They do tell us that A is a decreasing function. And I just think this logically, if my function A is decreasing and you draw a rectangle to estimate that. So I have my base of my rectangle right here. The left side of the rectangle is determining the height. And because this is a decreasing function, the rectangles will extend above the curve, giving us an overestimate. And our reason for that, I'm going to type this because it's faster. This is an overestimate because A of H is decreasing, and we used, or I used, whatever, a left-hand Riemann sum, and that's good enough. That's good enough for the explanation for why this is an overestimate. Okay, part C, we are still talking about the cross-sectional area, only this time they give us a function for the cross-sectional area, but it's the same situation. It's the same tank. We're not using the table anymore. We're using this function. And as I mentioned a minute ago, volumes in AP Calculus. Now, when you get to college, there are other voluming techniques, but in AP Calculus, volume is always found by doing the antiderivative of the cross-sectional area. And here they tell us that the area of the horizontal cross-section is f of h. So we will simply do the antiderivative of f of h dh, and it's the same tank. So it's still 10 feet tall, 0 to 10. Make sure you include the setup. If you don't write the setup, that is considered a bald answer. If you only write the answer and you get no points. And the answer to this one is going to be 101.325. 101.325. And you'll just throw that in a calculator. So you should know how to do definite integrals in your calculator. 325. So I'm not going to give you a calculator lesson here. Indicate units of measure. Make sure you include units when they ask. If they don't ask for units, then don't offer them. You only answer the questions that they ask. Don't volunteer information, but they did actually say indicate units of measure. And then part D, water is being pumped into the tank. When the height of the water is 5 feet, so we're looking at a time when the height of the water is 5 feet, the height is increasing at it. So that's H prime. This sounds like related rates. The height is increasing. That's DHDT at 0.26 feet per minute. Use the model from part C. So part C, we had an F of H. I'm going to have to go back and look at that F of H. Okay, so there's our F of H, just copied it over here. Okay, so use the model from part C, find the rate that the volume is changing. So we're looking for dV dt, which means I need a function that provides the volume. Well, the volume is always the antiderivative of the cross-sectional area, but you have to do a definite integral. Now we're talking about the water. We're not talking about the whole tank, where we have some tank that the cross-sectional areas decrease as we go up, and we're looking at the water and the height of that water in the tank. We're calling that H. So if I want to know the volume of the water, that's going to be the antiderivative from 0 to whatever that height of the water is of my function f of h. But since h is already used in the integral, we're going to, for the limits of integration, we're going to change my function to f of x. You don't want to have the same variable for the integrand as you have for the upper limit of integration. So it's the exact same setup, except we have to be able to plug in various values of h to get the volume of the function, or the volume of the water filling up the tank. So there's my expression for volume. This is a related rates problem. We're looking for dV dt. So to find the derivative of that volume, this is your fundamental theorem of calculus. dV dt is going to be, we replace the x with an h. That's going to be f of h. But you always multiply by the derivative of what replaced the x. That'll be times dh dt. And now we start plugging in what we know, and we want to find dV dt. I don't know why I swapped to green right there. Whatever. So we're looking for dV dt when h is equal to 5. And so that would be f of 5 times dH dt, but they tell us that dH dt is 0.26. And we will go to the calculator and punch that in the calculator. And when you do that, you will get 1.694. Always go to that third decimal, 1.694. And we have the f of h here. So you just plug in 5 to that function. Now, if your calculator is completely dead, they would accept the answer of 50.3 over e to the 0.2 times 5 plus 5, because that is f of 5 times the dH dt 0.26. And that would be accepted as well. So you don't have to get the decimal approximation, but it is a lot easier just to go ahead and throw that in the calculator to get a nice number. Indicate units of measure. So we do have units of measure needed here. We found volume over time. dV dt would be measured in, volume is measured in feet cubed, and time is measured in minutes. So there is your units. So that's the end of working this out. If you're curious about the scoring on this one, I'm going to spend the last minute talking about the scoring. So let's look at part A. Part A was worth 2 points. One is for showing the left-hand Riemann sum setup. That's what I was talking about. You must write down the base times the heights. And you got another point for the approximation value. That would be 176.3. However, if you stop with just the setup, that also counts for the approximation point as well. So just this alone, I thought I was underlining. This alone does give you both points. The units actually were kind of a separate point if you maintained correct units, because parts A, C, and D all asked for units. And if you included correct units for all three of those, you got a point. So it wasn't 1 point per question. It was 1 point for maintaining correct units throughout the problem. Number B, you must have answered overestimate with a good reason. That was just a 1 point question. So A was worth 2 points. A is worth 2 points. B is worth 1 point for the correct answer along with the explanation. C, you got 2 points, 1 point for the antiderivative, and you got 1 point for the answer. And again, the unit, if you left the units off, you could still get those 2 points, but you would fail to get that other point for correct units throughout A, B, and C. And then part D, this is a 3-point question. It says you got 2 points for the derivative, so 2 points here. And I don't know how they broke that down. They may have given you a 1 point, maybe if you had f of h but forgot the dHdt, or maybe you, I don't know how they graded that one, but it was worth 2 points. And then you got 1 point for the correct answer over here. So this is a 3-point question. And that is your 2017 number 1.